Hello everyone. Today we are going to discuss JEE 2022 24th June Shift 1 chemistry paper. So let's see the first one. Most stable trihalides from NF3, NBr3, NCl3 and Ni3 each. So it is a direct question. Okay, information based that NF3 is stable only. This is stable. And remaining all, that is NCl3, NBi3 and Ni3. These are explosive. These are contact explosive. When we touch them, they will explode. So they are very much explosive. And if we see the stability order overall, maximum is NF3, then NCl3, then NBr3, and then Ni3. Out of these, the most explosive is Ni3. And the least basic is NF3. This is least basic and most explosive. Most stable. And this Ni3 is most explosive. So the correct answer for the first one is NF3. Now let's move to the second one. Atom X arranged in HCP unit cell while Y atoms occupy 2/3 of tetrahedral void, then percentage of X in the unit cell each. Report your answer to nearest integer. Okay. So X is forming HCP. So we know that effective number of atom in HCP is 6. Hence the number of X atom will be 6. Now number of total tetrahedral void. Total number of tetrahedral voids in HCP is 2 times of effective number, that is 12. Now Y is occupying 2/3 of tetrahedral voids, so number of Y atoms will be equal to 12 into 2/3, that is 8. Now they are asking percentage of X in the unit cell. So percentage of X atom is what? Simply number of X atom, that is 6, divided by total number of atom, that is 8 plus 6 into 100. Okay, so this will be 600 divided by 14. Okay, if we just solve it, it will be around 42.857%, or we can round off to nearest integer as 43%. Okay, so the correct answer should be 43%. Now we'll move to next question. Question is, which set of quantum numbers represents degenerate orbitals? So we know that degenerate orbitals are the orbitals having the same value of n and l with different value of a. So degenerate orbital means having the same energy, so same value of n and l, but different value of m, different m. For example, we can say dxy, dyz, dzx, dx square minus y square, dz square. These all are what? Degenerate orbitals. Similarly, pxy, px, py, pg. Okay, all are degenerate orbitals if they have same number of principal quantum number like 3dxy, 3dyz, 3dzx, 3dx square, y square, 3dz square, and 3px, 3py, 3pz. So these two are different sets of degenerate orbitals. So in this case, n plus l values, n and l values should be same. So here n is 3, here also n is 3, l is 2, l is 2. So in the first, we can say this is a set of degenerate orbitals. Here n is 2, n is 3. These are not set of degenerate orbital. N is 4, n is 3. So this is also not. So the correct answer should be option A. Let's move to the next one. The EMF of the following cell, it is PT solid, H2, 1 atm, H plus, copper 2 plus, copper this much. Then find the value pH of anodic half cell. Okay, that is given. So this is the anodic half cell that is given. We have to find the pH of this. So we can just apply the Nost equation here. So before that, let me write the overall anode reaction and cathode reaction. So at anode oxidation occurs, so hydrogen gas will be giving you 2H plus 2 electron. This is the reaction that is taking place at anode, and anode cell for this is already 0 volt, that is SHE. Now pressure is 1 atm, so here I will write 1 atm. Now at cathode what will happen? Cathode reduction will occur, so copper 2 plus will take 2 electron and will become copper. Okay. Now for that anode cell is how much? 2 plus 2 copper is basically 0.34 volt positive. Okay. So now if you write the overall cell reaction, it will be H2 gas, that is 1 atm, plus copper 2 plus. Okay, and the concentration for this is how much? 0.01 molar. Okay, aqueous. Electron will be cancelled out. Then 2H plus aqueous. This concentration I don't know, that we have to calculate, plus copper. Okay. Now anode cell is simply 0.34, that is sum of these two. And now we'll apply the Nernst equation. Now Nernst equation is what? E cell equal to anode cell minus 0.0591 by n, okay, log q. Now anode cell is how much? 0.34 minus 0.0591, and they have already given that we have to take this value at 0.06, so we'll take 0.06. N value is 2 because 2 electron is involved. Log concentration of the product, that is H plus concentration to the whole square, by concentration of the reactant, that is partial pressure of H2 into concentration of copper 2 plus. Yeah, so that is the Q expression in this case. Okay, now further we'll solve it. E cell is given to us, that is 0.576, so that is equal to 0.34. This is 0.03 log concentration of H plus square. Partial pressure of hydrogen is 1 and copper 2 plus concentration is 0.01. 0.01 is what? When it will go to numerator, it will become 100. Okay. Now we have to solve simply and find the H plus concentration, right? So let me further solve it here. Okay. So it will be 0.576 minus 0.34 equal to minus 0.03, and now this part, it is how much? Log H plus concentration square divided by 1, and this will go to numerator, that is 100. That will be 0.03, and we can just write it as log 100 plus 2 log H plus. Yeah. Now log 100 value is what? It is 10 square, so 2 plus 2 log H plus concentration. Okay. Now further we can solve it as it will be equal to 0.06 negative plus minus 0.06 log H plus. Now when we subtract this, that is 0.576 minus 0.34, we are getting 0.236. That will be equal to minus 0.06 minus 0.06 log H plus. Now, so further we can write minus 0.06 log H plus is equal to 0.236 plus 0.06. Okay, and that will be minus log H plus. If you add them together, it will be 0.296. Okay, divided by 0.06, and that is coming to be 4.933, and this is basically the pH. So pH will be close to 5. Nearest integer is 5 because 4.933 we can just round off. Okay, and that will be equal to 5. That's the nearest integer they are asking. So correct answer for this will be 5. Let's move to the next question. C5H13 is used as a rocket fuel Then find mass of oxygen used per liter consumption of this. Also find mass of CO2 produced given density is this much. Okay. So density is how much? Density 0.576 gram per ml. This is the density. So 1 ml of this C15H30, okay, is equal to 0.756 gram. Okay. So let me write the combustion reaction first, like when it will be undergoing combustion. Okay, what will be the product? So C5H13, okay, plus O2, that will be giving you simply CO2 plus water. Okay, that will be the product. Now if you balance this, total carbon is 15, so I will write 15 CO2. Then we'll balance hydrogen, that is 30, so here again I will write 13, so 15 H2O. Now total oxygen, right hand side is 30 plus 15, that is 45, so here I have to write 45 by 2. Yeah, so that is the balanced reaction now for the combustion of this rocket fuel. Now what we need to calculate, find the mass of oxygen used for per liter consumption of this, per liter consumption of this. Okay, so listen, density is this much na? So we can say 1 ml of this fuel is equal to 0.756 gram. So 1000 ml, that is 1 liter, is equal to how much? 756 gram. So this is actually 756 gram. We are doing the combustion of 756 gram of that. Okay, now the molar mass of this will be how much? It will be 12 into 15 plus 30, that will be equal to 210. That is the molar mass. So what is the mole? Mole is 756 by 210 mole. Okay, so it is 756 by 210 mole, that is equal to 3.6 mole. Now we'll apply the mole concept, that 1 mole of this rocket fuel is producing, it is consuming 45 by 2 mole of oxygen. So mole of oxygen consumed will be simply 45 by 2 times of that. Okay, so 3.6 into 45 divided by 2, that will be 81 moles. So 81 moles of oxygen is used, and 1 mole oxygen is 32 grams, so it will be 81 into 32, and that will be equal to 2592 gram. Okay, so 2592 gram of oxygen is used, so this option is gone because they are asking oxygen used. This is also gone. Now either it will be 1 or 3. So second, what we have to calculate, mass of CO2 produced. Okay, so 1 mole of this is producing 15 mole of CO2, so mole of CO2 produced will be 15 times that of mole of C5H13, so it will be 15 into 3.6, that is 54 mole, and its mass will be simply 54 into 44, because 44 gram per mole is the gram atomic mass, so it will be how much? 2376 gram. So 2376 gram, that is the first option. So here it will be the first option here. Okay, let's move to the next question now. Next is, what is the concentration of glucose solution in intravenous injection in gram per liter, which is isotonic with blood solution, which has osmotic pressure of 7.93 bar at 300 Kelvin. So we know that for isotonic solution, osmotic pressure, that is pi of that injection, should be equal to the pi of the blood. Okay, osmotic pressure of the blood solution. Okay, now we are asking what is the concentration of glucose solution in intravenous injection. Basically that is equal to, suppose CRT equal to pi of blood, and the blood is how much? 7.93 bar. This is the blood osmotic pressure. Now what is the value of R? Concentration we have to find. R is 0.082. Okay, and the temperature is 300 Kelvin. That will be equal to 7.93. I we have to take as 1. It's not mentioned, so it is non-electrolyte. And it is 7.93 divided by 0.082 into 300. Yeah. So if we just do it, we are going to get 0.322 molar. That is the concentration of glucose. Now, they are asking in gram per liter. So this is molar, means mole per liter. So to convert into gram per liter, we have to multiply it with the molar mass of glucose, that is 180 gram per liter. And this will be equal to 58 gram per liter. Okay. So the correct answer for this is 58. Now, let's move to the next question. Which is not present in teeth enamel? So teeth enamel, we know that it's a apatite that we have 3Ca3PO4 whole 2 dot CaOH whole 2. Now, with the fluoride that is present in the toothpaste, it will convert to fluoroapatite, and now it will become Ca3PO4 whole 2 dot CaF2. Okay. Now, this is apatite, that is fluoroapatite. So these are the ions, that is calcium 2 plus, phosphate ion, in which phosphorus is in plus 5 oxidation state, and fluoride ion. These ions are present, okay, in the teeth enamel. So calcium is present, fluoride is present, P plus 5 is present. Which is absent? That is phosphorus plus 3 oxidation state, that is absent. So it is the third option. Now, how many of the following oxides are amphoteric in nature? So Na2O is basically alkali metal oxide, so it is highly basic in nature. AS2O3 and Sb2O3, these arsenic oxides and antimony oxides are basically amphoteric. So this is amphoteric in nature. NO, N2O, these all are neutral, and CO, so neutral. N2O is also neutral. And Cl2O7, that is anhydride of perchloric acid, is highly acidic. So this is highly acidic. So how many of these are amphoteric in nature? So amphoteric is H2O3. That's all. H2O3 is the only amphoteric, so that is the second one. Okay. Some other amphoteric oxides that you should remember is BeO, ZNO, Cr2O3. Okay. Then you can remember PbO, PbO2, SNO, SNO2. These all are amphoteric oxide. Neutral oxides are basically NO, CO, N2O. These all are neutral oxides. Okay, so let's move to the next question now. A cation Y2 plus on reaction with reagent X forms rosy red or red color complex, basically, that is red given, not rosy red. Okay. Then they are asking basically the cation Y2 plus and the reagent X are respectively. So that is very important and very basic questions. Okay, that is of qualitative analysis, as well as we study this in coordination compound. That is NiDMG2 complex. So Ni2 plus with the DMG, 2DMG, that is dimethyl glyoxymeto. Okay, we get the complex that is NiDMG whole 2. In that, basically, this complex look like this. See, we have carbon, carbon, methyl, methyl. Okay. After that, it is N, then it is O negative. Here it is OH. So it is glycinato, OH. Now this side also we have the same. Now here it will be O negative, and here it will be OH. This will be involved in the hydrogen bonding, so let me write it here. That is the intramolecular hydrogen bonding. In the whole molecule itself, this is the hydrogen bond basically, and nickel here is 2 plus, that is the central atom, and this 4 nitrogen is acting as a ligand. Okay, so this is a square planar complex. dsp2 hybridization, and it is rosy red. Okay, so rosy red color complex. So the correct answer for this will be nickel 2 plus with ammonical solution of dimethyl glyoxine. Okay, let's move to the next question. Which is used for commercial production of dihydrogen? That's the dihydrogen preparation. If you see commercial, we use a steam, okay, on carbon, basically on coke. This is the coke, and we react it with a steam, okay, and temperature is around 1270 Kelvin. We get what? Carbon monoxide gas and hydrogen gas. Okay, so this is basically the commercial production of dihydrogen that will yield the dihydrogen. So the correct answer should be what? Carbon, that is the first one. Now match the following. We have the following species: PCl5, PTCN4 2 plus, CONH3 whole 6 3 plus, and BRF5. So we have to match the hybridization. PCl5, you know, is trigonal planar geometry, TBP geometry. So TBP is what? sp3 hybridized, sp3d, sorry. This will be B. So first we'll be matching with B. This is con. Second, platinum with coordination number 4 is always be a square planar complex, so it will be dsp2. So second will be matching with D. Okay, so up to that it is okay. Third, CONH3 whole 6 3 plus, that is an octahedral complex, so it will be basically D2sp3 because ammonia is a strong field ligand. Okay, a strong field ligand, so it will be pairing occur, so it will be D2sp3, that is inner orbital complex. And BRF5 is a square pyramidal, basically, so it will be sp3d2, that is the last one. So the correct answer should be what? Option A. Now the next question, these all are direct from NCERT. And CO2 CO8, this, you know, metal carbonyl, number of CO bonds and terminal CO carbon monoxide bond is Y. Then find the value of X and Y. So first we need to just draw the structure of this, that is CO2 CO8. The structure will look like this: CO terminal, it will be carbon monoxide, and then it is CO and CO. So number of cobalt metallic bond, that is only one bond. This bond, we're talking about this bond, this is only one. And now with cobalt carbon monoxide terminal bond, so these are basically this bond 1 2 3 4 5 6. So the value of X is 1 and the value of Y is 6. So X plus Y is 7. That's the answer. Now next, we have to match the following. These are the important ores that we should know. Calamine is basically ZnCO3, that is the calamine zinc carbonate. Asphaltite is basically ZnS. This is ZnS. So calamine is what? Zinc carbonate. Asphaltite is what? ZnS. Galena, that is PbS. So very simple question. Siderite, that is iron carbonate, FeCO3. So if you see, the correct answer should be 2. First will match with B, second will match with A, third will match with C, and fourth will match with D. Let's move to the next one. Now, which of the following statements is the correct set of statement? Okay, the first is B2H6. You know, B2H6, this is the structure of B2H6, in which total of 6 atoms are in a plane, 2 hydrogen atoms are out of the plane. B2H6 is a Lewis acid. Yes, it is a Lewis acid because it is electron deficient. The boron has only 6 electrons. B2H6 is a planar structure. That is wrong because these 2 hydrogen are out of the plane. Other 6 atoms are lying in the same plane. All the BH bonds length are equal in B2H6. No. Suppose this is X and this is Y. Y is greater than X. Terminal is shorter in length. Okay. Now in B2H6, 3 center 2 electron bond are present. That is also wrong. It has only 2. This is the one bond, that is 3 center 2 electron bond, and this is the another bond, that is electron deficient bond. So it is 2 bond present in that, so this is also wrong. So among the following, the correct set of statements that we have, and one more is there, B2H6 can be prepared by reaction of BF3 with NaBH4. That is correct, because BF3 will react with NaBH4. BF3 will give H minus, NaBH4 will give H minus, okay. So on heating, basically it produces H minus, and all the fluorine is replaced by H minus, forming BH3, that will dimerize to form B2H6. And this F minus will now form NaBF4. So correct answer for this is what? A and E both. A and E both. That is the second one. Okay. Now, statement 1. In emulsion, oil in water gets separated into different layers. That is true, because in the emulsion, the dispersed phase and dispersion medium has not much interaction. Okay, so they can separate into different layers on standing. Now, it can be stabilized by adding excess of electrolyte. It is stabilized by adding the surfactant, okay, or emulsifying agent, but this is not excess. A small amount is enough. So the statement 2 is incorrect. So the correct answer is S1 is true and S2 is false.